All right, thank you very much. Thanks for having us. My name is Dominik Kistner. I'm from the SAP Gardener team. I'm together with my colleague Raphael Franzke today. Give you an introduction in Project Gardener, or in more detail about the work stream, which is that we call autonomous shoot clusters. But before we dive into that, I would like to recap a little bit on the IPSIDE-SYS. Actually, the IPSIDE-SYS, as you probably know, aims to build a sovereign, secure and interoperable European multi-provider cloud edge continuum. That's for me always a little bit a heavy term to pronounce. So in essence, it is an initiative to create an overarching continuum, which is open for any kind of infrastructure, platform, or service provider to integrate, and which is spanning over from cloud environments or onto the edge. With the ApeiroRA reference architecture, SAP is contributing to this initiative. So ApeiroRA is SAP's ongoing project for the IPSIDE-SYS. Within ApeiroRA, SAP is bringing in or contributing some key building blocks, such as infrastructure provider blueprints like the Iron Core project, Cobalt Core project, a bare metal automation layer, which helps you to automate data center resources, a platform mesh, which makes it easy for service providers to integrate their offerings, a bunch of operational and security services, and a multi-provider managed Kubernetes offering, and many, many more. We all combine that in ApeiroRA with an overarching concept to build a holistic stack, reaching from the data center on the bottom up to the software as a service layer and on the top. So within ApeiroRA, we proclaim a so-called operating system, a cloud operating system, which we use to build a higher level services on it. So the cloud operating system actually at all is not a single service. It's a bunch of central services that you require to build applications, like it's an identity provider, identity and account management, identity and account management, an IaaS provider. And that can all be leveraged to build higher level services on top. One of the design principles that we apply in ApeiroRA is that we don't use individual individual machines anymore as the base unit, so to say. We are building everything on top of clusters where we can run containerized application and services on. So in essence, Kubernetes. And as you can imagine, for such an endeavor, building up such a stack, you require a lot of Kubernetes. You require it in a homogeneous way. You require it across different providers. So it's not feasible to go with individual handcrafted Kubernetes clusters. You need instead a managed Kubernetes offering, which can offer you the things. And that is where Gardener comes in. So Gardener, the Gardener project offers you fully managed Kubernetes homogeneously across all different providers. What does it actually mean? It is independent where Gardener brings your cluster or where you bring a cluster with Gardener, you have the same kind of capabilities and management options. So you get the same configuration options for your Kubernetes clusters, the same Kubernetes versions you can select. You can also and manage all of your clusters or your fleet of clusters from one central point or out of one central service, which makes it, of course, very easy to manage a lot of clusters, as we said, that we need for building such a stack. Gardener also comes with a extension concept, which makes it super easy to plug in any kind of infrastructure that you want and run a cluster on it. So be it on a hyperscaler or in your private data center, or even on the edge with Gardener, that's easily possible and to achieve. Now I want to dive with you a little bit into the Gardener architecture. So for that, I wanted to start in the right. There you see the term shoot cluster. And the shoot cluster actually in Gardener, in Gardener is actually an end user Kubernetes cluster. That's the cluster where you can run your application, your containerized applications in. And Gardener is leveraging the hosted control plane or kubeception model, which means we are hosting the control plane of a shoot cluster within another Kubernetes cluster that we call the seed cluster. And of course, in one seed cluster, we cannot only host one control plane, we can host there many. And we also have in Gardener a central management plane or control plane where you can specify your clusters, or can do the where you can manage actually your clusters. We have on each seed a central Gardener agent that we call the Gardenlet. It's very similar like to Kubernetes, where you have the kubelet running on each machine, which is responsible for managing the containers on the seed, or the pods and the containers within on a worker node. We have in Gardener on each seed a Gardenlet running, which is responsible for locally managing the control planes and the clusters on this hosted on this seed cluster. You as an end user, you are talking to the central garden API, and you specify there your cluster. So you do it completely declaratively with you specify a Kubernetes cluster with a Kubernetes as a Kubernetes custom resource, and then it will be picked up. It will be scheduled to a seed cluster, and then the Gardenlet on that cluster will take care to create the cluster, and of course also taking care about all the lifecycle operations on the seed for the shoot cluster. And as said, you cannot only have that's way what it looks like. So you have here a shoot manifest. In this example here, you have a shoot cluster that I call my shoot, and I want to have it here. I declare I want to have it running on Kubernetes 1.30, and I want to have it on provider OpenStack. That's of course just a very minimal example of a shoot manifest. You can have much more details, but for instance, you can completely customize the control plane and all of that of the Kubernetes cluster, and you can do it on whatever on any kind of provider which is available to the Gardener system. Which means you can also bring additional seed clusters to plug in additional cloud providers or regions. It's just and of course host them there the respective end user cluster, shoot clusters for your end users, or for the Gardener end users. All right, and with having that introduction, what most important to recall, shoot cluster is an end user cluster we hosted on a seed. The Garden cluster is the central unit or the service layer where we actually configure your cluster centrally, or where you can configure your cluster centrally, and they get then managed by the Gardenlet onto the different seeds. Now I want to talk with you, or look with you a little bit on the cloud edge landscape, because where we position Gardener therein. And you see here, for instance, Gardener is with the working quite well in cloud environments, or in let's say regional data centers that usually have consistent network connectivity, or where you usually have consistent network connectivity, where you have APIs to automate things, where you, for instance, can request virtual machines or network resources or storage or whatever else, where you have failure domains, which means, for instance, you have a concept where how to distribute your workloads, like availability zones, and making sure that they are run in a failure tolerant mode. And in this way, the hosted control plane model of Gardener works very, very well. But in the IPsite sys, we want to go even further on the left in this on this landscape. So we want to reach into the edge, and there we have usually the problems that network connectivity is not always given. Or that you don't have APIs to automate things, you don't have failure domains and all of that stuff. So just assume you have a cluster running, I don't know, in a factory somewhere in the back, in a factory, or you have it somewhere in the office running, or even on a ship, an airplane, whatever. Many cases are possible for an edge scenario. So therefore, we are introducing in Gardener a new concept, or a new kind of clusters that we call autonomous clusters, or to be in our terms, autonomous shoots. And they will help with these kind of scenarios. Let's look at, let me introduce that a little bit to you, what it actually is. So an autonomous cluster actually consists out of some worker nodes, obviously, and control plane nodes, where we host a control plane. So you may ask, in essence, that's like a traditional Kubernetes cluster that you also get if you craft it by hand, or if you use tools like kubeadm, K3s, whatever else. But the difference that we're making is we are putting also the Gardenlet and some other Gardener-specific components that I didn't depict here, and connect the cluster to the Gardenlet, to the Garden cluster, so that we can consistently manage it centrally from the central central service layer of Gardener, so that that you can control your entire fleet of clusters from one central point. That means if you have registered it, you get for the autonomous clusters also in the garden cluster a central representation, and you can continue to manage it from there on. I want to look with you a little bit also on network boundaries or isolation domains and why they matter for the case, and especially for the edge. For that, I brought in here also another figure of a, let's say, traditional or regular shoot cluster. And here you see the worker nodes and the control plane nodes, they are running in different domains. So you have usually the shoot cluster worker nodes running in one network domain, which is usually controlled by and owned by the owner of the cluster, so to say, or the end user of the cluster. You have the seed cluster usually running in a different networking domain, usually owned by the operator of the Gardener service. You have the garden cluster running in a different network domain. But for the autonomous clusters, we package both together within the same network domain. And this has the big advantage that the network connectivity between these two things is always will be always stable or more stable. They are in the same networking domain, which means if you think about running on the edge, if you, for instance, my example is always having here, I have a seed cluster running in a harbor, and I have a shoot cluster running on a ship. So probably the ship doesn't have network connectivity all the time to the harbor. So in this case, you would have a problem with the traditional approach, because the cluster, actually the shoot cluster, is not functional if the control plane is not available. Therefore, we package them together, and we also want to provide options that you can temporarily disable it without having any issues. So we still want to provide air gap capabilities so that you can run the cluster or air gap the cluster for a while and make some modifications in the central Gardener. And once the cluster is available again and can connect back to the garden cluster, it will fetch, or the gardenlet will fetch the details and will run or will then do the lifecycle operation. That could be, for instance, I say I want to upgrade all my Kubernetes cluster from 1.30 to 1.31, and only once the autonomous clusters can reach the garden cluster, the gardenlet will get this kind of information and will run then the lifecycle operation. So with autonomous shoots, we also have defined, let's say, a few different scenarios that we want to cover. Actually, we have one scenario that we call the unmanaged infrastructure scenario, and we have another one that we call the managed infrastructure scenario. I want to start on the left with the unmanaged scenario. That's actually the scenario where you only have, let's say, a bunch of pre-built servers, so you don't have any kind of automation layer to request machines. You just have a pre-built setup of machines which are connected via networking, but there's no mean to automate anything here. So you cannot request a virtual machine or something like that because you simply don't have an API for it. Then you have the case which we call the managed infrastructure case. That means there are APIs to certain things, so you can certain things automate, like compute, storage resources, and maybe also networking. And in this case, we can leverage existing Gardener and Kubernetes platform integrations to automate things for building up an autonomous shoot cluster. So in this scenario, we have either a complete automation layer, or we have just a partial automation layer. So it's thinkable that you can maybe automate or request virtual machines because you maybe have something like a vCenter or so, but you don't have network. So that means hybrid scenarios in between are possible that we can use, or that you can are thinkable. And then I want to go to this picture here because it's very important and shows the architecture of Gardener, or the key principle. We have the central Gardener in the middle as one central platform to manage all your clusters in the same way, independent where they're running. If they're running on the with a hosted control plane mode, so the traditional mode or the regular mode of Gardener, with seed and shoot clusters, usually fitting quite well for the cloud. You manage them in exactly the same way like you do it for autonomous clusters who might running in a factory or wherever else, where you don't have capabilities to automate things and where network is maybe separated. So these clusters, they're running within the central gardener side by side, doesn't matter, and managed in the same way like regular shoots side by side. Okay. Now you might ask, okay, how do I build up such an autonomous shoot? Said with Gardener, with the central approach, you usually just go to the central garden, you specify a custom resource, a shoot custom resource, define there how your cluster should look like, you post it there, and then the gardener will take care to create your cluster. But how are we doing it in case there is no automation layer, so nothing Gardener can leverage? For this case, we invented actually a new command line tool that we call the Garden ADM, which helps us to bootstrap autonomous clusters. It is actually using the same configurations that we are using also for regular shoot clusters. So it's not like kubeADM, which might come to your where you think of. kubeADM and other tools, they are following a rather imperative approach. Garden ADM is using a declarative approach to define the clusters and managing it. And then, of course, it also helps us to connect this garden to connect this cluster later on to a central garden. And now I want to give you an example of for an unmanaged infrastructure scenario. How to build up a cluster with Garden ADM. And for that, you are here in the middle, you're the operator, and you want to build a Kubernetes cluster. What you actually have is a bunch of servers. They're called A, B, C, D, and E, and they are connected via network, so they can reach each other. So what you first would do is, you have, of course, the Garden ADM tool. The first thing what you usually could do is you could try to discover an existing gardener and to get some configuration. Because to build up the shoot cluster, you need some kind of information, like about the environment that the cluster should be running in. We call this in Gardener cloud profile, or the kind of extension, so the additional functionality you want to have on the clusters. These kind of configuration you could get from the central garden if it is available. You can get it there, and with the Garden ADM discover command, you will get them and fetch these kind of configuration for the cluster that you want to build up. In case it is not available, then you need to provide it manually, but it's not an issue. You can do it. But it's of course more handy if you have it. And then we will start to create a cluster. So what we will do is we will jump on the first machine, we will run the Garden ADM init command, and with that we make out of these 5 servers, out of the first one actually, we make it to a control plane node, and we put a control plane on top of it. And then what we probably want to do next is we want to join a few more control plane nodes, maybe 2 others, so that we can make the control plane with an etcd cluster highly available. And for that, we are generating a bootstrap token, and then we jump on the different machines and we run Garden ADM join. And then the other servers B and C will join A and will be registered as a control plane node in the cluster. Next, you probably want to have some worker nodes where you can run them or where you can then deploy some workload on. And for that, you can run again the Garden ADM join command, or first you run the token command to generate a bootstrap token again, and then you join the other 2 worker nodes to the cluster, the other 2 nodes as worker nodes to the cluster, and then you have it. And at this stage, you have a fully functional Kubernetes cluster. You can do whatever you want with it, but it's somehow unmanaged. It is there. And now comes the trick, actually. We want to connect the cluster now back to a central gardener. And for that, we have the Garden ADM connect command. And with that, we install the gardenlet onto the seed, onto the one of the control plane nodes. And it will then call back to the central garden cluster and registers actually this cluster as a shoot cluster within the central gardener environment. And from there on, you can talk to the central gardener and you can modify your shoot manifest. For instance, you can say, hey, now I want to trigger upgrade the Kubernetes version of this thing. And then the operation will be done, handled by the gardenlet in place in the cluster. And that is what we want to show you now with a demo. And for that, I hand over to Raphael.
Great. Thanks, Dominic. And also hello from my side. Let me share my screen. And with that, we can get started with the demo. So actually, we are here in the kind of unmanaged infra scenario. We simulate this with a kind cluster on my machine. So what I've basically set up is just a very basic one node kind cluster, not any special configuration whatsoever. And here we have a namespace for Garden ADM where we have two pods, machine 0 and machine 1. And let's say these pods are simulating your nodes in the edge. So those are basically just like VMs or machines that have an operating system. They are booted, but there's nothing installed in them. And you can now exec into them or SSH into them and run commands. And this is what we will basically do now. So here we have exec into the machine. And we will now first look into the configuration that we have provided to it. And Dominic actually explained with the Garden ADM discover command is that you need some configuration of how the cluster should look like in the end. So you have here, for example, the registration of an extension called provider local, which runs in some version. There are some other extensions registered here for networking, the Calico and the Cilium extension, and so on. It's not so much important. If you are familiar with Garden, you might recognize most of them. The most relevant resources at the top, which is the shoot manifest, the declarative cluster specification. And if you know it, it looks quite similar to the regular shoots with the seed architecture. There's one difference here, which is that you have a worker pool that is marked as control plane worker pool, meaning that the control plane components are now supposed to be self-hosted and running in this cluster instead of running in a seed. So that's basically it. You have a file or many files, basically a folder where all this resides. And this you can now use in order to run Garden ADM init. You just point it to the directory where the configuration is stored. And then this runs. For the sake of time, I have already pre-executed it because it takes some minutes until all this gets up. But in the end, as explained in the slides, you will now make this node, Kubernetes node, in the first control plane machine, basically. So let's have a look on it. It should be ready in a minute. Yes. So now it's done. It tells us that the control plane has been initialized successfully. We get some information on how we can now talk to the cluster, where the kube config resides. We will do it in a minute. We also get some information how we can now join additional nodes to this cluster. And finally, the most important thing, how to connect this cluster to a Gardener eventually. So let's start with looking what we have created here. There's one node in the cluster called machine 0. And the pods in the kube system namespace are not too special. They are typical system components like kube proxy, Calico, CNI, core DNS, and so on. And of course, also the control plane components of this cluster running as static pods. So we have etcd, API server, and so on, the usual suspects. And if you are familiar with Gardener, you notice that we are basically reusing existing functionality that we have already built. So etcd Druid, which is our etcd operator, managing etcd clusters, is used here as well in order to bootstrap the etcd nodes. Then we also have our Gardener extensions running here. So in this case, provider local because we're in this local kind environment, but this could also be if you have a managed infrastructure, AWS or whatever else. And of course, the networking extension. This is all here in the cluster and basically self-contained. So now you have a ready cluster. You also have a backup bucket here for the etcd of the cluster. So the data is backed up in the local environment. This is more or less a host directory mapped from my machine into this container setup. So we could check it out here in this local backup buckets folder. There is this name F5E, which corresponds to the name of the backup bucket here. And if we take a look what is inside, then we find there's a full snapshot and every 5 minutes an incremental snapshot. So the usual backup and restore functionality that we already have. All right, and now with that, you can basically start deploying workload and use the cluster, whatever you want to do with it. What you eventually probably need to do if you deploy more and more into it is joining additional nodes and scaling the cluster. And this is what we will do next. For that, as shown in the slide, there is a command called token used for managing Bootstrap tokens that then can be used for Garden ADM join or also later for connect. So if you are familiar with kubeADM, this should not be much different to you. There is a Garden ADM token create, and you can tell it to directly print the join command for this created Bootstrap token. So this is the token that we got. There's a big CA certificate in here. There's a flag pointing to the configuration for the node that is to be joined. So this contains like the kubelet config and so on. And finally, the address of the control plane where the to be joined node needs to talk to. And yeah, executing this list again, we see that this Bootstrap token is this one here. It has a default expiration of an hour. And yeah, eventually gets also deleted when it expires, but you can also delete it yourself if you want to. So let's go to machine 1 and let's watch the nodes here to see what happens when we execute this command. We basically just copy paste it. It tells us that this node has been instructed to join the cluster as a worker node. And this is what we expect to see here now. Machine 1 is coming up. It's not ready because all the system components have to be initialized. But this will happen eventually, and then the node will also be marked as ready. So note that this is the worker node, it's not a control plane node. But for control plane nodes, the command and the flows should actually look similar. All right, so as said, you can, if you want to, delete the token that you just used manually in order to invalidate it, or you just wait until it is expired and garbage collected. So now that we can deploy workload and add nodes, we still need this day 2 and lifecycle for the cluster as such, as Dominic already explained. And for this, we, of course, want to use the same declarative approach with Gardener that we also use for clusters that we run on the cloud, for example. In order to demonstrate that, we go back to the kind cluster. In the Garden namespace, I have prepared Gardener deployment. So with the help of this Gardener operator here, we see that we have the Gardener API server and the other Gardener components that belong to its control plane. There's also this Garden custom resource that depicts that there is a Gardener instance here. And we can now talk to it and list the seeds. There are no seeds at all because I didn't install any. They are not needed for this demo. Just want to show you that there is an empty Gardener that we can now use to talk to and connect this autonomous cluster. Again, in order to connect it, we need some kind of authorization and authentication. We create a Bootstrap token. There are none currently. So similar to how this works for the join, we can also let it directly print the connect command. Here we also have to tell it which shoot namespace and which shoot name this token should be related to, because we don't want it to be used for other things other than registering exactly this shoot. And then this command actually looks very similar to what we saw before. Garden ADM connect, some Bootstrap token, now the CA certificate of the Gardener and the address of the Gardener API. If we list them again, we can see in the description that this is a token that is used for connecting exactly this shoot that we specified via the Garden ADM connect command. All right, so otherwise, same workflow. We copy this, we go onto the machine, paste it here. We start watching the shoots, execute it and see what happens. The shoot manifest now gets registered in the Gardener, and we see that this command is still running, now deploying a gardenlet into this autonomous cluster, which is then just like it's also doing it for seeds and shoots. It's watching this manifest and reconciling it every now and then, making sure that the specified state is also the actual state in the cluster. So if we check the pods, there is now a deployment of gardenlet. And what we can do now is, as before, or as we are used to basically with clusters in the cloud, edit the shoot declaratively, change whatever we like, whatever setting. Maybe this we want to increase, save it, and then the gardenlet here will make sure that it is rolled out. Another thing that you might wonder is how this gardenlet here is now kept up to date, because sometimes we have new versions. You want to roll this out to the autonomous clusters in the edge. And for this, we have a resource called also gardenlet in the Gardener API. This usually represents a deployment of a gardenlet in a seed, but it can now also represent a deployment of a gardenlet in an autonomous cluster. So let's take a look. For example, what can you do here? There is the image specification of the gardenlet repository and the version. So if there's a new Gardener version, you could, for example, just dump it here, and it then gets updated. You can also modify deployment configuration like CPU memory requests, or you can modify whatever else is gardenlet specific, so its configuration. If you want to change something here, you can also do it. For the demonstration, we just make a simple change here and increase the memory requests. We watch again the gardenlet pods. And when I now save this resource, the gardenlet immediately starts to roll out. So it's basically self-upgrading. It's watching this resource and redeploying itself with a new configuration and maybe in a new version, if there would be a new version. All right. And what else do we have? If you check the help command of the Garden ADM, besides the things that you already saw, Discover I didn't show you, but it's also just the convenience method for downloading the configuration. Another important command is this bootstrap command. So this is useful when you have a managed infrastructure where you have an API that you can use to, as Dominic said, create machines, create networks, create storage, whatever. Let's say AWS or whatnot, so some kind of cloud provider API. If you have that, then you can use the Garden ADM Bootstrap in order to let Gardener prepare your infrastructure, meaning it might create a VPC and subnets and use the machine controller to create VMs and prepare all this. What you basically need to do manually in an unmanaged infrastructure scenario on the edge. So this means that you can use autonomous shoot clusters also for cloud environments if you have special requirements. Most importantly, you can use them to bootstrap Gardener itself, because somehow you need some Kubernetes cluster in the beginning in order to deploy Gardener to. And this is also a goal actually for the autonomous shoots. If you want to learn more about this command, because we don't have the time to show it here, we coincidentally have a presentation about it in tomorrow's Gardener review meeting, which happens bi-weekly on Wednesdays from 9 to 10. I will post the link in the chat. If you would like to join, just reach out, and then you could also see a demo for this scenario. And with that, I will hand back to Dominic.
Thank you, Raphael. Awesome. So, okay. Going back to wrap it up, I would like to give you also a little bit an overview about our plans and the upcoming milestones for autonomous clusters in Garden ADM. So, as Raphael mentioned, one of the goals for autonomous clusters is also to solve the so-called first cluster challenge. So you might ask, what is that actually? Actually, our first wave is part of the Garden enhancement proposal that we wrote for autonomous clusters, GAP 28. And what actually is the first cluster challenge? For that, I want to go back a little bit to the beginning, where we talked about the ApeiroRA stack and said everything is built on top of Kubernetes. And you just see in the beginning of the layer, Kubernetes is somewhere in the middle of the stack. And way below under Gardener. So, and as we learned, Gardener is also requiring Kubernetes to be set up, same like for the infrastructure provider blueprints that we offer and the bare metal automation. So we need actually for all of that Kubernetes. And after the session, you probably know where this should come from. Of course, it is an autonomous, or should be an autonomous shoot cluster that we build with Garden ADM init and join. And once we have done this, we can deploy these kind of applications on or the services on top of this autonomous shoot clusters or the autonomous shoots. And once the Gardener is then up and running, we can also connect it via Garden ADM and close with that actually the circle. So it's a little bit like that here, like the Baron Münchhausen, who's trying to hoist himself out of the swamp. So we are also trying to pull out ourselves with the burden of managing Kubernetes in the very beginning where you don't have anything. We are doing that completely closed within our ecosystem, the same means that we have for any other kind of cluster in ApeiroRA. So, and that beyond that, actually, we want then in the second wave to enable also our end users to connect autonomous shoot clusters to the Garden, which means that we enable edge use cases for end users. But for that, we have certain things that we need to work on, and that will be handled in a follow-up Garden enhancement proposal. There will be questions open like, yeah, how can the air gap handled? How long, for instance, can a cluster be air gapped? These kind of questions need to be clarified, but we also have a lot of technical questions that we need to solve. So for instance, the Gardenlet is a component designed to run on a seed. So in the operator space of Gardener, so to say, with autonomous clusters, they are now coming into the user domain. So there's probably some questions open for access control, but also with respect to scalability and VPN and many more. Yeah, with that, I would like to wrap it up. Thank you very much for your attention. And I think we have some time left for Q&A. In case you have some questions, please go on.
I think there's one question in the chat from Valentin about turning back an autonomous managed cluster into an unmanaged one. Actually, there are two questions. Okay, but turning back the cluster into an unmanaged one is possible by deleting the shoot from the Gardener and then removing the Gardener deployment from the cluster. But yeah, I don't know why this could ever be needed, because with that you would lose the lifecycle operations and cannot further maintain the cluster. So I'm not sure why this would ever be done by somebody. As for deletion of the cluster, in the unmanaged infrastructure scenario, it's completely the responsibility of the user to handle the infrastructure. So that means the user has to prepare the networks, the user has to somehow prepare the machines. And if they want to get rid of it at some point in time, of course, there's no knowledge in Gardener or Garden ADM what was done before, so the user has to do it. The user has to tear down the machines, delete the network configuration, and so on. The managed scenario, this is handled by Gardener. So with the Garden ADM Bootstrap, we use the Gardener extensions, we use Machine Controller Manager. They are preparing all this, and they can also be used to tear it down again. Hope this answers it. Another question in the chat, is Garden Linux required as an operating system for the nodes? Actually not. So of course, Garden Linux is the preferred operating system for Gardener, but yeah, Garden is open source. There are many OS extensions, Ubuntu, Flatcar, whatnot. You can write your own, so it's not hard-coded in Garden, so to say. You could also use something else. And another one, qualification criteria for adding server hardware. I guess this is about sizing of the servers, right? And how big they are. So of course, it depends. Like in cloud environments, you can use different machine types depending on what you want to deploy in the end. Of course, Gardener comes with some preload for the system components, managing components. We have not yet written this down, but once this gets closer to production, we will prepare a date for it, of course.
Okay, thank you.
Yeah, with that, I would like to thank you, Raphael and Dominic, for this very interesting presentation, and would hand over to Keith for the
Thank you.
sustainability talk.
Thanks.
Thank you. Bye.